Uh, my name is Vikramaditya and I'm going to discuss today kinematics. Kinematics of a particle, that is particle kinematics, that means all the bodies will be considered as particle, and a rectilinear translation. Rectilinear translation means motion along a straight line. तो मैं आज बात करने वाला हूँ किसके बारे में, वो kinematics of a particle and a straight line motion. And इसमें कई cases होते हैं. बाकी kinematics, what is called kinematics, what does it mean? I have perhaps made a video on this. And if you didn't see it, kindly look for it, you will find it. So पहला situation क्या है? What is the first situation I'm going to discuss today? I'm going to discuss today the motion with constant acceleration. Suppose we have a particle moving along x-axis, its initial position being x0 at t equals 0. t equals 0 पर का condition मैं discuss कर रहा हूँ कि initial position of the particle is x0. Here is the origin where observer would be sitting. Observer यहाँ पर होगा, origin पर होगा, and its initial velocity is suppose that v0, and there is an acceleration, constant acceleration. That means acceleration is independent of position, velocity and time. Then these are the initial conditions of motion, and at any time t, particle will be somewhere at any point p and its velocity will be v. Simple to consider. अगर इसकी velocity v है, ये किसी भी direction में move कर सकता है, लेकिन अगर इसकी velocity v है और acceleration, if the acceleration is constant, you can write its equation of motion simply as dv by dt equals a. Acceleration can be defined as rate of change of velocity, and to do other things, this is a differential equation. Though this is a differential equation, first order, first degree, you might not recognize it, but you will recognize one day that this is a differential equation. Variables separable, so you should separate the variables. There are two variables in this equation. One is time, that is permanent variable, and another one is velocity. Acceleration is constant, and constant may go either side. So I am going to put this constant with dt and keep dv on the left of the equation. That is called separation of variables, and now you should integrate them. Take your limits. Time starts from 0 and t is any arbitrary moment in between the motion, and initial velocity is v0, and at any time t the velocity becomes v, and you can solve it to find v minus v0 equals at, and that gives you equation v equals v0 plus at. और इसमें दो variables हैं. Here are two variables. One is velocity and another is time. And if you try to plot velocity in terms of time, it will give you a straight line, simply a straight line, because this is a linear equation. So if you want to try it, it can be like this. Well, it cannot be always like this. हमेशा यही नहीं होगा, लेकिन एक प्रोटोटाइप मैंने बनाया है. इस किस्म का ग्राफ इसका होगा. If you can do some other thing like you can put since the motion takes place along the x-axis, v can be easily written as dx upon dt, and if you write dx upon dt in place of v and write the other things as it is, or then after this is also a variable separable. V naught is a particular value of velocity, so it's a constant. Acceleration is already constant. Time is the variable, and here x is the variable. So you need to identify both the variables, and again separate the variables like we did earlier, and the equation you got is like this. And then if you want to integrate them, you should integrate them like dx equals v naught dt plus a t dt, and a is a constant, so before integrating you can take out of the integration sign, and time starts from 0, and any arbitrary moment is simply t, so I write here, and then at initial moment the x was simply x naught, and any arbitrary moment I am giving the value of x as simply as x. So the integration gives you x minus x naught, left hand side of integration. Right hand side begins with v naught t, and then a t square by 2, and so you have the exact equation to find the x coordinate of the particle at any time t, and that is x naught plus v naught t plus half a t square. You perhaps remembered it like you must have written somewhere in your class 9 or in class 11. S, if you replace x minus x naught simply by s, then the equation you get here is s equals ut plus half a t square, that is v naught t plus half a t square, and like this. You can draw s in terms of t like this. S versus t graph will be a parabola or something like this, or you can draw x versus t as well, and this will be something like this, like part of a parabola. And you can get more of the equations, but I need you to solve a problem to practice this first. And इस प्रॉब्लम की हिस्ट्री बहुत बुरी है, लाइक मैं भी कभी बच्चा था, अभी जितना बड़ा हूँ उतना ही बड़ा सब दिन नहीं था, कोई नहीं होता, टाइम के साथ सब कुछ बदलता है. Someday, at some point of time, मेरे दिमाग में एक क्वेश्चन आया था. उस क्वेश्चन की वजह से मुझे काफ़ी परेशानी हुई थी ज़िंदगी में. मतलब कुछ लोग थे जो काफ़ी बड़ा मान गए थे उस प्रॉब्लम को पूछने के कारण, वो मेरे दिमाग में यूँ ही आ गया था. उसके कारण मुझे कहीं से कहीं भेज दिया गया. बाकी बहुत सारा टाइम मैंने हॉस्टल में गुजारा है. सो दिस इज़ द प्रॉब्लम. एंड द प्रॉब्लम इज़ what is the minimum distance in time t that a particle and of course the particle is moving along a straight line, call it x-axis. that a particle moving with constant acceleration a can travel. This is the simple question. What is the minimum distance in time t that a particle moving with constant acceleration a can travel? Can you solve it? The particle is obviously moving along x-axis. Origin is somewhat here. And हमें गैस चूल्हा नहीं बनवाना, हमें तो इस प्रॉब्लम को सॉल्व करना है. When I thought, when I was very young, I thought there may be three cases. Three cases are possible here. Like first case can be, let the particle is at the origin, and because I can take origin anywhere, so मान लिया कि particle origin पर ही है शुरू में, इसकी velocity है कुछ u और इसका acceleration भी positive x-axis की direction में है. तो किसी टाइम t पर इसकी जो velocity होगी वो इधर की ओर होगी. ये लेफ्ट हैंड साइड का कंडीशन t को 0 पर का कंडीशन है, and this is at any time t. Then we can have a second case as well. I just thought, and I just thought it in when I was in class 9. Suppose the particle is at origin at t equals 0, and it has a velocity u in this direction, along the negative x-axis, and acceleration is towards right. So particle will be somewhere here, moving with velocity v at time t equals t. It can be one of the conditions. And another case is possible, that is case number 3. Suppose the particle is at origin, its acceleration is in this direction. It will be always, because particle is moving with constant acceleration, so its magnitude and direction remains constant, so it is always moving along the positive x-axis. But its velocity was initially u, and this u is less than this u in the second case. और किसी टाइम t equals t naught पर, ये t equals 0 पर का कंडीशन है, at time t equals t naught, the particles comes to rest here. If the particle comes to rest here, it will change its direction in exactly opposite direction, because acceleration is here. In this condition, I am assuming that particle is moving in this direction, always moving in this direction, though this will not be the case for always. But particle is, this u is greater than u, and it has come to rest here, and then it has started moving in this direction. And at any moment, at any time t, its velocity is v like this. So in the first case, I am assuming that for all the time t, let me write it in a particular manner. I am assuming here that t is greater than or equal to 0 and its total time of journey is tau, or in the problem it was given that the total time period was t, so I am going to write tau here, and this tau is any particular moment during the motion, because whole journey time is given as t. टोटल टाइम जर्नी का टी स्मॉल टी दिया हुआ है, सो मैं बीच में का कोई किसी टाइम को टाउ मान लेता हूँ. दिस इज द कंडीशन, and in this case u is greater than 0 along the positive x-axis and acceleration is also greater than 0. This case the time can be again written as, and for the whole time I took u is less than 0 and a is greater than 0. And in case 3, tau less than 0 to t naught, the u is greater than 0 in the initial velocity, and acceleration is u is less than 0 and acceleration is greater than 0. Acceleration is in this direction, velocity is in this direction. And for the time t naught to t, the velocity v is greater than 0 and acceleration is greater than 0. So I have taken these conditions. If I would like to justify a few things again, I can take this, I can write this v instead of u, so that things will become more clear. That this means, it means velocity is always along the positive x-axis, it means velocity is always along the negative x-axis, and in this case I can always change this thing. That velocity, initial velocity was along negative x-axis between 0 to t naught time, and after them its velocity becomes positive. So there are 3 cases possible in this motion. And if you consider the first case, case number 1, this case number 1, you will be definitely writing the equation that the distance traveled in time t is s equals ut plus half at a square. ut plus half at a square. And you can conclude that S1 is greater than equal to half at a square. S1 will be equal to half at a square if u is equal to 0. So you should conclude this result from the first case, that the distance traveled in first case is greater than equal to half at a square. Now if you consider the second case, distance traveled is in this direction, so nothing is going to change, but just write this S2 equals the equation you would like to write here, ut minus half at a square. Because this displacement is in this direction, u is in this direction, so if u and displacement S2 are both taken positive, then A must have been taken as negative. So you can write this equation and you can manipulate it like ut plus ut, not plus, but ut minus AT square plus half AT square. You can always write this because minus AT square plus half AT square ka value minus half AT square is, this thing is going to happen minus half AT square. So you can do one more thing. You can write it u minus AT multiplied by t plus half AT square. And then you can see here u minus AT is the velocity at any time t. In case 2, v, this v is u minus AT, and so you can write it Vt plus half AT square. So S2 all in this direction should be taken as positive, and I wrote something like that. And mathematically we know that S2 is also greater than equal to half AT square. Equal to half AT square when V is equal to 0. Otherwise S2 is greater than equal to half AT square. So these two conditions reveal two different results, two same results. Now I am going to consider the case 3. This condition. I am going to work in the time frame when my time is less than 0 to t naught. And is in this condition, and in this condition, since it travels a distance this, so I am going to call this S3A, part 1 of S3, and I can write here S3A equals, because this is in this direction and u is also in this direction, I can write ut minus half AT square. But this distance has been travelled in time t naught. So the S3A distance should be written like this, because I have taken that. मैंने ये बताया है कि ये distance travel हुआ है t naught time में. So the first part of the distance S3 you can write like this. And at time t naught, velocity becomes 0. Time t naught, velocity becomes 0. Velocity, the particle stops there, because it cannot take a U-turn if it doesn't stop. So particle stops at time t naught. So v is equal to 0. So put v equals 0 here, and you get u equals AT naught. That means you can write S3A equals A t naught in place of u, and there is again a t naught, so you will get AT naught square minus half AT naught square, and the result you will get the part 1 of S3 as half A t naught square, only half A t naught square. This is one result, but next part is, for the next part, the time is now t naught and t. I am considering the journey between t0 and t. यहाँ से ऑब्जेक्ट मुड़ चुका है and its initial velocity was 0. So second part of S3 can be written as from the formula S equals ut plus half at square. So its initial velocity is equal to 0. So you can write simply as half at square, and that is going to be half a t minus t naught square. You already spent this t naught time. So rest of the origin of time has been taken at the moment when the motion starts. So you can write this thing. So the whole of the S3 you would like to calculate will be S3A plus S3B, and S3A is half a t naught square and S3B is half a t minus t naught square. So we can do rest of the calculations simply by considering a by 2 as a common, and this thing will become t naught square plus t minus t naught square. And then you can write it a by 2, just break this square, t naught square plus t square plus t naught square minus 2t t naught. And you got what? You got a by 2 t naught square minus 2t t naught plus t square. And this is S3 basically. We are calculating S3, and I am going to take this 2 inside this square bracket so that I can write it S t naught square minus t naught plus t square by 2. And I want to do something like I want to do like this. Just multiplied this thing, just multiply this thing by 2 and divided by 2. So I can get a square minus 2 t, this was t naught square in fact, t naught square. So a square minus 2ab, and now I need the b square, so I can write it as t square by 4 minus t square by 4, so that these two and this one will make a perfect square, and it will become a t naught minus t by 2 square plus t square by 2 minus t square by 4 will become t square by 4. This is our S3. And since this is a square, t naught minus t by 2 square, it must be greater than equal to 0. That means S3 is going to be greater than equal to at square by 4. So, what was the question? I forgot. Let me read this again for you. The question was simply, what is the minimum distance in time t that a particle moving with constant acceleration, A can travel. So the minimum distance is S3 and its value will become equal to AT square by 4. This is your answer. Of course, T0 will be 2T, I know for sure. For this condition, we have to make this 0 and T0 will become T by 2. So halfway you have to stop somewhere on the left. And this is your answer. And I'm planning to solve more problems. But this was the problem for the people who want to think. Because I want people to think. I want them to think. If you don't want, you can become a good teacher. But if you want to become an engineer, you should start thinking. Thank you very much for watching.